Now we're going to do the exact opposite. We're going to be given the KSP and try and find the concentration of the ions in solution. KSPs are values you can just look up in a book. I found these for those particular substances right out of your textbook. So it says, what would be the concentrations of the ions in a saturated solution of silver bromide? Just like always, the first thing you have to do is write down your equation. In this case, solid silver bromide will break apart into silver aqueous and Br minus aqueous ions. Once you have that, you can write your KSP expression. KSP is concentration of Ag plus times concentration of Br minus. We don't have to put the AgBr because that's a solid. In this case, I don't know what the concentrations are. That's what I'm trying to find. What will be the concentrations? So I'm looking for the concentration of Ag, and I'm looking for the concentration of Br minus. What I know is the KSP. So this KSP value I'm going to stick right here, 5 times 10 to the negative 13 in the equation. Well, from math class, if you have an equation and you don't know a number, we use variables. So since I don't know what silver is, I'm going to plug in X for silver. Well, that's good. So I know that silver is X, but now I need to find the bromide concentration. Well, if you look at the balanced equation, every 1 silver bromide gives me 1 silver and 1 bromide. So I know that silver ion to bromide ion is a 1-to-1 ratio. So if I've got X silver, I also have X bromide. So I can plug in an X right there for the bromide as well. I now end up with my KSP, 5 times 10 to the negative 13, equal X times X. And X times X is X squared, not 2X, it's X squared. And then to solve for X, all you have to do is square root both sides. And when you do that, you get a value of X equaling 7.1 times 10 to the negative 7. And we said X is what silver concentration was. So my silver is 7.1 times 10 to the negative 7. Concentration is measured in molarity, so you need the units there. Bromide was also X, so that is also 7.1 times 10 to the negative 7 molar, and this would be the answer. The concentrations of silver and bromide are both 7.1 times 10 to the negative 7 molar. I'm going to try one more example. This time, my substance is lead iodide, but I'm going to do the same thing. You start with your equation, PbI2, which is a solid. That will break apart into Pb2 plus and I minus. Both of those are aqueous. To balance the equation, I need a 2 there. Once I have that, I can write my KSP expression by simply taking concentration of Pb2 plus times concentration of I minus, and that has to be squared. The question says, what will be the equilibrium concentrations of the ions? So in this case, I don't know the concentration of the lead ion, and I don't know the concentration of the I ion. That's what I'm trying to find. What I do know is the KSP. So I have it written here, but you could have just looked it up in a book, in a table, could have Googled it. Your KSP is 1.4 times 10 to the negative 8 for this particular reaction. I have no idea what lead and iodide are, so I'm going to use variables. I'm going to pick X for lead. That would be easier because in my balanced equation up here, the lead has a prefix or a coefficient of a 1 there. And it's easiest to put the X with the substance with a 1. It'll work both ways, but it just makes the math a little bit more complicated. So if lead is X, How does lead compare to iodide? Well, for every 1 lead, I get 2 iodides. So if lead is X, iodide is twice as much, 2X. I can now plug them into my expression. Lead, we said, was X. The concentration of iodide is 2X. And whatever that concentration is needs to be squared. So 1.4 times 10 to the negative 8 equals X times, when you square 2X, 2X times itself is 4X squared. When I take X times 4X squared, you get 4X cubed. And now I can simply solve this equation for X. First thing you need to do is divide both sides by 4. And when we do that, we get X cubed equaling I don't know, I better check. 1.4 times 10 to the negative 8 divided by 4 is 3.5 times 10 to the negative 9. And then to solve for X, you need to cube root that. And when you cube root that, you get 0.00152 for your X. So I now know the concentration of X, which was lead, is 0.001. Let's see how many significant digits I had. Looks like only 2. So 0.0015 molar. And to double that one, to find my iodine, is simply 0.0030 molar. And then you have your answers. Notice you don't double it and square it. Once you find your lead, which was X, to find your iodide, you just take it times 2, and you get your concentration of iodide.